All right, guys, so we are to the last topic of the year. We're going to talk about limits. We are going to do a broad overview of limits, but there's really only a specific kind of question on the test. So your whole row. Anybody else have it? All right. So at the beginning of the year, we talked about end behavior. And we kind of use this notation as x approaches infinity, y approaches. This meant the right end, right? What was the graph doing on the right end? So was it going up or was it going down? That's pretty much what we did for end behavior. Once in a great while, there was a few that approached some constant value if there was a horizontal asymptote. And we're going to talk more about end behavior and those in a few minutes. We're going to talk today about limits at a particular point and what makes something have a limit and when it doesn't have a limit. And we're going to talk about limits at infinity, what happens on the far left and far right, but I will tell you that part is not on the final, okay? All right, so when you get to calculus, there's basically two things you spend a ton of time doing. Finding the equation of a line tangent to a graph at a particular point, and all the reasons you would need to do that. And then finding the area between the graph of a function and the x-axis. And lots of applications of when you would need to do that. So the limits have to do with those, okay? The solutions to these two kinds of problems, you have to understand what a limit is. So this is the concept that we kind of talked about, but we didn't really do much back in the beginning of the chapter 1. We just talked about whether something was discontinuous or not. And we talked about end behavior. But there was a section back there that talked about limits. The idea is that as you get closer and closer to a particular x value, say this one is C right here, they say. So as I go from the left and get closer or from the right and get closer, if I am getting closer and closer to the same value from the left and to the right, from the right, that y value that I'm getting closer and closer to is called the limit. The problem is sometimes a graph doesn't get close to the same limit from the left, same value from the left and right, and then it doesn't have a limit there. It also, this graph had a hole, so even though this graph is undefined at C, it can have a limit at C, as long as it is approaching the same value from both sides. All right, so our first example on this slide, and you don't have this one, this notation means as x approaches 2. What is the limit as x approaches 2? This is a solid line. There's no holes in it anywhere. So as I go from the left or from the right, I could type in numbers closer and closer to 2. Does everyone understand that these numbers are getting closer and closer to 2? From the left, because from below, right? Less than 2. Or closer and closer to 2 as we come from above 2? What's happening to the y value? Because the answer is always the y value. What's the y value doing? It's getting closer and closer to -5. That means this has a limit of -5 as x approaches 2. That's it. Okay, doesn't seem too complicated. As we go down this line from the left or from the right, as we get close to x equals 2, we end up at the value y equals 5. Matter of fact, we could just plug a 2 in and we'd get out a -5, yes? That's called direct substitution, and we'll talk more about that tomorrow. This graph, you can't do that. Why can't we not just shove a 3 in here and get an answer? Because it has an asymptote or a hole or something at 3, right? Because it makes the denominator 0. That doesn't mean that there can't be a limit, okay? When the value of the function, when plugging the value in makes it undefined, we can still have a limit. As we get closer and closer to 3 from the left, like 2.9, 2.99, 2.999, are we approaching the same number as if we were coming from the right? 3.1, 3.01, 3.001. They're both getting closer and closer to 6. That's numerically, it's called. This is graphically. If we look up here, we're getting closer and closer to this same empty circle as we approach 3. And that empty circle is at 6. Okay, so the important thing to know from the graph is you want to know the y value. What y value is it approaching? Okay. And from the table, same thing as you go from the left or from the right, what's the value of y or f of x? All right, so we're going to take our calculator. And because we want to be able to numerically check things, we're going to go to okay, first of all, sorry, mode, just do radians and functions because there's a couple trig ones. You want to be in radians. Radian and function mode. Been a while since we had to have function mode. All right. And then if you go second window, we're going to do ask auto so that we can put in things like 2.9, 2.99, 2.99 as we get closer to 3. Does that make sense? We want it to just let us type in what we want it to calculate. All right. Here's the definition. You actually have this on your sheet, kind of. I'll talk you through it in a second. But even if there's a hole at C, the limit will be L, so long as it is getting closer and closer from both the left and the right. Does that seem okay? This has a value up here, but that dot still means nothing as long as this is getting closer and closer to a particular value L. As you come from the left or the right, the limit is L, not that value up there. And this one, it just hits L at that point. So as you come from the left or the right, you're still getting closer and closer to L. So that the value can be undefined, it can be defined somewhere else, or it can be defined at L. But the limit of all of these graphs is as x approaches C, the y value L is the same on all of them. So that's the limit. So it's important to understand that a limit is not about what happens exactly at that value, but what it is approaching. Okay? A limit is about what happens near or close to that number. And then the other thing to remember is that the limit is the y value. It's not the x, okay? So let me see. Can I find one we could just do before we get to one-sided limits? Oh, come on. I thought we could just pick. You know what? I'm going to do this. Okay, I'm going totally the wrong way, so I'm going to do nothing. I thought I was right where I needed to be. All right, before I put up the next one, if we have a graph like this, and I ask you, what is the limit at -1? And this value is, we'll say y equals 0.5. If I ask you the limit as x approaches -1, you would just say 0.5 because on either side of -1, the graph is staying at 0.5. Does that make sense? If I ask you the limit at right here, we'll say this is x equals 7. And if that was y equals 3, at 7, the limit as x approaches 7, it's going closer and closer to what y value, or at what y value? 3. Okay? Now, That's not true here. If this is at x equals 1 and I ask what the limit is at x equals 1, as x approaches 1, it doesn't have one because one side is staying at negative 0.5 and one is up here at 3. So since there's a break and the left and the right side are doing different things, we would say does not exist. What we're going to talk about is that it can have a left-hand limit of negative 0.5 and a right-hand limit of 3. That notation is written like this. This means, okay, as x approaches c from the left or as x approaches c from the right. In other words, what's it doing as you come from the left? What's it doing as you come from the right? Sometimes they only want to know that. Sometimes they'll then move on and ask, what is it actually doing at C, or what is the limit at C? All right, and this notation can also be written as approaches C from below or approaches C from above. I'll say left or right, but it can be read below or above. All right, the limit exists at C, like this, if and only if it's approaching the same value from the left as the right. Have I said that enough times yet? Okay. On your paper, it says a left-hand limit is approaching from the left, right-hand limit here from the right. But if those are not equal, then a limit doesn't exist. If they are both the same, then that L value is the limit at C. All right, here's some examples. Everybody looking up here because you don't have this, okay? This asks what is the limit as it approaches 0 from the what? Left. Okay, as I get closer and closer to 0 from the left, what y value am I at? Can you tell? Negative 2. Okay. Can you tell what y value we're at down there? Negative 2. Okay, that's this one. Then it asks what happens as it approaches 0 from the right. So as x gets closer and closer to 0 coming from the right, this graph is up at positive 2. Okay. So what happens if I ask you the limit at 0? Since the left was approaching one value and the right was approaching another, we say the limit at a two-sided limit does not exist. Okay. Here's another example. This time, as we get closer and closer to negative 3 from the left, what y value are we at? Can you tell? 4. As we get closer to negative 3 coming from the right, we're still at what y value? 4. So even though it's undefined, or at negative 3, it's actually down at negative 2, right? Does it matter? We're talking about the limit. If it's approaching from the left, it's approaching 4. From the right, it's approaching 4. Guess what the limit at negative 3 is? 4. Okay, the limit exists and it's at 4. Even though the graph jumped down here to negative 2. The limit just means what's it doing really close. Now, if you look up here, it says it's actually 4 for every single value except exactly negative 3. So negative 3.01, negative 2.99, it's always 4. So therefore, the limit is 4. All right. The first two examples I have for you are ones you would have to mess around with a little bit because they're piecewise functions. I graphed both piecewise functions in y1 and y2. It looked like this. The rule says it's the cubic to the left of 1. So to the left of 1, it's doing this. And then this piece is erased. Remember how we would draw these and erase part of it? Okay. It's the line to the right of 1. So that's this piece. But what do you notice about these? Do they overlap? They ran into each other at 1 here, right? So it was this on the left, and then it was straight over here. So the question is, what's the left-hand limit for 1? As I get closer and closer to 1, coming from the left, what are some numbers to the left of 1? 0, 0.9, 0.999, are those just to the left of 1? Okay, and it's the cubic, so it's this rule. What is that approaching, guys? 3. Okay, from the right, some numbers just above 1 would be 1.01, 1.001, 1.0001, yes. And what happens? Actually, it's on the line, so it's approaching 3 still. So does it have a limit at 1? All of these were approaching 3, weren't they? All right, that was a little confusing. This one, y1 is the line. So this is negative 0.5x plus 2, and y2 is the parabola. Now, what do you notice? The rule says to the left of negative 2. What is this doing to the left of negative 2? It's going down. What is it doing to the right of negative 2? Totally lied. Okay, it's supposed to be on the line to the left of negative 2, right, guys? I'm going to say this is negative 2. I really don't know if it is, but to the left of negative 2, it's linear. To the right of negative 2, it's the parabola. My bad. So we're crossing this off. These are not here. Okay. What's happening to the left of negative 2? What is it getting closer and closer to? Can you tell? Here, okay, what's the first number to the left of negative 2? Negative 3 is the next integer, right? So these two numbers are to the left of negative 2. Do you agree? Okay. To the left of negative 2, it's supposed to be this equation. What is it getting close to? 3. All right. But to the right of negative 2, it's supposed to be using this equation, which is in y2. What's just to the right of negative 2? Negative 1.99, all that good stuff. So what's it getting closer and closer to? Negative. This one was up here at positive 3. This one is down here at negative 4, yes? Do you see what's happening? There's a break in the graph, yes, at negative 2. So is there a limit at negative 2? All right. You have this one on your paper. As you approach negative 2 from the left, no, positive 2 from the left. Here's positive 2. As I get close, I'm writing on the little graph here, as I get close to positive 2, what y value was I at? 1. The second one says 2 from the right, okay? So I'm starting at 3 this time, and I'm going to get closer and closer to 2 from the right. What y value is that at? Okay, so does a limit exist at 2? Nope, because to the left of 2 and to the right of 2 were 2 different y values, so this does not exist. All right, now just to throw you right away, they say, okay, well, a limit cannot exist, but we can still describe what's going on. This one says at 4, the limit at positive 4. So here's positive 4. If I put a 4 in, I get a 0 in the denominator. What is this called? A vertical asymptote, yes? Okay. What's happening to the left of that vertical asymptote? It's approaching infinity, right? It's going up, 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 up. If we go from the right, what's it doing? It's approaching infinity. All right. Neither one-sided limit actually exists because infinity is not a real number. We can't ever answer the limit is infinity. Okay? So we have to say it does not exist. However, we can describe both of the behaviors by writing the limit is approaching infinity. Now, this is what I'm going to have you do. This is not proper, guys. But I'm going to have you write the limit does not exist and then write it approaches infinity. Okay? Because I don't want you to get confused. In order to not confuse you on the final, none of the choices will say infinity. Okay? So you won't be confused because you won't pick that. But there could be does not exist or there could be none of the above. But the answer is never infinity. All right. So this is again reinforcing that. It says, when it says approaches infinity or negative infinity, these are descriptions of why these limits fail to exist. The symbol infinity and negative infinity are not actually real numbers, so they cannot be the limit. So here's a question. What's going on to the left of 0? Can you tell? Just to the left of 0, this graph is doing what? It's going down towards negative infinity. Everybody okay? Here's some values to the left. Look what's happening. It's getting really, really negative, yes? Okay, to the right, just to the right, this graph is doing what? To the right of 0? It's going up, yes? Look, I put some numbers in just to the right, and I got really big numbers, yes? 10 and then 100 and then 1,000. Closer I got. So the right-hand side is approaching infinity. What's it doing at 0? Doesn't exist. It really doesn't exist to the left or right, but it definitely doesn't exist at 0 because it's going both ways. All right, there's one more thing that can happen. A graph can oscillate in a tiny, it's not periodic. All day we've been confusing the fact that the cosine and sine graphs always oscillate, so to speak. They go above and below, right? But they do it at a set pace, okay? It's called periodic. They're repeating. An oscillating graph means as it gets closer to some value, it actually goes more erratically up and down. Here's a limit as the sine approaches 1 over x, okay? So I took my calculator, I made sure I was in radians, I typed in the sine of 1 over x. I did a zoom 7 for trig. I couldn't really tell what it was doing in here. I could do a zoom in to see what it's doing in there. Look what's happening. Woo! Do you see how crazy it goes in there? Okay. When it goes crazy like that, the limit does not exist. It's called oscillating. We had a little discussion about this 5th period because if I pick any one little value in there, just a little bit to the tiny bit to the left or right, I could find a number. All right, but because if I went out a little bit further, it would jump around and do crazy business. And I'm not going to ask you this on a test or quiz. You'll study it some more next year, okay? But when it does that crazy business, the limit doesn't exist. Is this doing crazy business? Look at this picture. As I get close to 0, it looks like it's getting close to what? The y value is 0. As I get close from the right, 0. This one does have a limit. It's 0. Even at 0, it says it's 0. Okay? I just want you to know that just because it has a sine or a cosine in it doesn't mean it doesn't exist. We'll do some more. All right, so here's when it doesn't exist. If it approaches a different value from the left and right, everybody okay? If it increases or decreases without bounds, so infinity and negative infinity are not limits. And if it oscillates, then it doesn't have a limit at that point. All right, so here's the first few questions. Does everybody, if I were asking you to do this at home, could you know how to get to absolute value? Do you remember? It's under math, arrow to the right, and then it says ABS. And it doesn't mean anti-locking braking system or whatever. Okay. All right, so the graph actually does this, guys. It's got a piece down here and a piece up here. It's really weird. What is the question asking us to decide? Yes, the limit from the right, a right-handed limit. What is this doing as we come from the right towards 0? It is at 3. That's it. Okay. Question number 2. All right. This asks about the limit at what? -2, which is over here. This is -2. This is -2 on my graph. Okay, it's undefined at -2, but it asks about the left-hand limit. Does this have a left-hand limit at -2? So you come from the left, what's happening? Okay, we say it does not exist, but we can describe it. What is it doing to the left of -2? It's approaching infinity. Okay? The back of the book for that question would just say infinity. But I want you to be very clear that that's not actually a limit. So I'm going to say does not exist, but it approaches infinity. Okay? What if I change this to a right-hand limit? What's this graph doing coming from the right? It's actually going down, right? So it'd be approaching negative infinity, but it still would not have a limit. All right. This one does not, this is a two-sided limit. It wants to know what's happening on either side of 2. Can it be 2, guys? Can we do direct substitution? If I put in a 2, it's undefined. But look up here. If I type in 1.999 or 2.001, what happens? Okay, for the first time, I'm hearing a lot of discussion about whether it exists or not. Okay, everybody's okay with that? There is no value. It's undefined at 2. But since both sides, look at the graph here. It's really hard to tell because it goes off the top. But this is 2 over here. X is 2, okay? The y value coming up the line this way or down the line this way, the y value is the same, and it's apparently 7. Everybody okay? Do you need me to let you do one of these with your calculator? This is called the graphic approach. This is the numeric approach, okay? And you can use both on the final. You get the same answer. It's approaching 7. All right. Now, before I let you do one on your own, this one is confusing to students. Because remember I said this is a periodic function, yes? The cosine? 1 minus cosine squared, it's going up and down, but it's not really oscillating. It's doing it at a set period. Okay? The question is, does it have a limit at 0? As I approach 0 from the left, what's it getting closer to? As I approach from the right, it's getting closer to. So what do we say? Yep. The limit as x approaches 0 is 0. Even though it's bumping up and down, doesn't matter. It has a limit because it is periodic, not oscillating. All right, over here. At 3. Me too. Yes, yes. Okay. Yep. So what's going on at 3, guys? The left-hand limit would be negative infinity. The right-hand limit, well, it doesn't exist, but it would be going up. Look, if I put in 2.999, I get negative 6,000. If I put in 3.001, I get positive 6,000. Are those the same value? Does not exist. Yes. All right, guys, number 6. On either side of -2, this graph is doing what? Yeah. It's going up, yes? Do you want to do it with the table? If you typed in 1 divided by parenthesis x plus 2 parentheses squared, and you went to your table, what are some values just below -2? That's above. -2.01, -2.001 are numbers close to -2, but further negative, right? Closer to 0, if we put in -2, we get an error. But closer to 0 on the right-hand side would be things to the right of -2 would be -1.9 or -1.99. Okay? Both sides are very large, yes? It's not approaching a single number. I have 100, I have 10,000, I have 1,000,000. That's not a single number. So both sides are approaching infinity. Does that matter? Well, it matters that we can describe it, but it really doesn't have a limit. Does not exist, but both sides approach infinity. Number 7, I typed it in with a parenthesis around the top and a parenthesis around the bottom. Does it have an exact value at 4? No, but look what's happening. It looks like a line, right? So over here at 4, it must have a hole, right? Because it says down here, when I typed in a 4, I got nothing. But look what happens on either side of 4. Where is it at? 3.99 and 4.01. It's approaching what? It's approaching 8. We need the y. We need the y value. When I put in 3.99, I got 7.99. When I put in 4.01, I got 8.01. So it is approaching 8. Students get confused, and you'll go to take the final, and you'll put an X value. It's a y value you want, okay? Yes, you're right. Okay, guys, this is the 8 and 9 are the same question. What's the difference? One wants the left hand and right hand. Okay, here's the graph. Here's -1. What's it doing to the left of -1? As you get closer and closer, it's going, does not exist, but approaches negative infinity. Okay? Does not exist from the right, but it's going up, so approaches positive infinity. I don't know what I'm trying to write. Okay. Now, we're going to talk about limits at infinity, which are really end behavior. What's happening on the far left and the far right, okay? This is not on the final. We're going to say what's happening on the far left. That's right. Just kidding. Positive infinity is the right, yes? Okay, what's the right end behavior? And this one, if it said negative infinity, would be what's the left end behavior? All right, so this question right here, as x approaches infinity means what's it doing on the what? The right end. Can you tell what this is doing if we go forever to the right? Look, I put in bigger and bigger values and the got tinier and tinier, yes? So we would say this approaches 0. Again, limits to infinity are not on the final, but they're on the homework. I think a couple questions. What's this doing on the far what? Left. Can you tell? Look down here. Far left, it's getting closer and closer to 2, okay? This graph has a horizontal asymptote. You remember that whole fun chapter? Okay. This graph, well, while it is oscillating, okay, it still can have a limit. And the left-hand side, what is this graph approaching? 0. So it has a left-hand limit of 0. On the right hand, as it approaches positive infinity, it's, yeah, oscillating, so it has no limit. All right, this is off your worksheet, guys. It says, what is the right-hand limit if it exists? Can you tell what this is doing on the right? Here's the graph, and here's some numbers. What is it getting closer to? Okay, approaches 0, it says. So we're going to answer for this question. Number 10, does it want the left or the right? Right. Okay, so I put in 9, I put in 99, I put in 9999999. Now, I got to tell you guys, there's no reason. I should have put in 1,000,000, 100,000, 10 million. I'm just lazy, okay? I'm just pushing 999,999. 1,000,000 is bigger than 999, right? Okay, just making sure we're all clear on that. But what happens out there at those big numbers is it approaches what? 2. Okay, what's different about 11? A left-hand limit, so I got to put in, well, it's not actually, it's approaching negative infinity. It's the left end behavior, okay? When I put it in, I had to put parentheses around the top and the bottom. I put in negative numbers getting more and more negative, and what did it approach? So you get how you would do this if you were doing this yourself? You could just scroll to the left, but you might have to scroll a while, okay? But just type in a really negative number and you'll be good. Now, is number 12 oscillating? No, this is just a periodic function, right, guys? We understand that a cosine, this is a question I could put on the final. Graph the cosine of 2 pi x. It just has a period of 1, okay? But what is the far right-hand side doing? If I keep going, isn't the graph going to continue to do this? So is it going to approach a single value as I get further and further to the right? No. Even though we don't say it's oscillating, it's not approaching a single value, so it does not exist. I typed in 9, 9.5, 10, 11.25, and I got a 1, a -1, a 1, and a 0, basically. So it was just a mess, okay? It's going up, down, up, down. Right-hand side. This one wants to know what's it approaching on the far right. What does this mean? 0.000000. I don't know if I have enough, but it's basically 0, right? Donut. I drew a donut. It's a big 0. Okay. Right-hand side. This is what the graph looks like, guys. I looked at the graph and I thought, well, it's getting really big, but then it gets up and then it goes down and then it goes up. If I go off to the right, I had a big number and then all of a sudden I had a negative number, right? So this one does not exist. What do you think about 15? Be careful. It wants to know negative infinity. So on the far left, I put in -9, -999, -99999, -1,000,000. It does keep going down, right? This one is -1,000,000. So we're going to say it's actually approaching what? It does not exist, but it will continue to go down, negative infinity. Does not have a limit, but it is going down, negative. All right. This is not an infinity question. This is a question you could easily have on the final. What happens as this approaches 0? So what kind of numbers might we put in? -0.1, +0.1. -0.01, +0.01. Yes? Okay, I put a bunch of those in, and what did I get? At 0, I got an error, but close to it on either side, I got 2. The limit is approaching 2. It's getting closer and closer to 2 from both sides. Everybody see that now? Make sense? All right. Number 18 is about an exponential what? Try again. 0.7 means it's decaying, yes? The car is depreciating in value. So somewhere over here it would start at 30,000 and then it's going down. Okay? I made my window kind of big because it said we had to go out 20 years, and so it was kind of a hot mess. Can you tell what happened at 10 years? Right here it says the car was worth oh, 43. Yeah, I can't read. 847.43. What do you think is going to happen to that car eventually out towards infinity? Yeah. This is a depreciation equation, and it's given as an exponential decay, so we're assuming the car is not being taken care of, it's being worn out, it's not becoming an antique, okay? One more. I graphed this hot mess in the calculator, and it started out at like 2.5 or something, and then it grew, but what happened? Look at here. On the far right, it approaches what? Okay, wait a minute. What was the value at 8 hours? Can you tell? 3.7 grams. Okay. Guys, the bell didn't ring. Your homework is to work on worksheet 2. No book work. It's printed for you on worksheet 2. Some of the questions don't give you an equation. They only have a graph. We can talk about some of those examples tomorrow if they're giving you trouble, okay? You can't test numbers. You're just going to have to look at the graph. Is it approaching the same value from both sides? Yes? Then you give me the y value. If it's no, does not exist.